In this video, we are going to be looking at matrices, which is a form of just taking coefficients of systems of equations to simplify the processes that we can use to solve systems. And matrices are used a lot within computer calculations because they minimize the code that has to be written because the variables are not written x, y, z in this particular case. We're not going to focus too much on this simply because there are calculators that will do these calculations, handheld calculators and also calculators on the internet, but I want to just show you some of the background information. So here in this first slide we have a system of equations, and what we've done is taken away the variables x and y and written it in this format of what's called a matrix. You can see that the coefficients are the same. The first column represents the x variable. The second equation represents the y variable. And then everything that's on the right side of this vertical line are what's on the right side of the equals, right? So on the right side of the equation. We have, in this case, 2 rows and 3 columns. And we use the variable m to denote the number of rows, n to denote the number of columns. So this particular equation is a 2 by 3 matrix, rows by columns. In the last video, we talked about Gaussian elimination, which gave us a set of rules that we could use to solve a system of equations. We could interchange rows, multiply a row by a non-zero constant, or combine 2 rows together by adding them. Those are the same operations that we use with matrices to rearrange everything and solve them. We used to spend more time solving matrices by hand. We would try to get things into row echelon form, where we would have leading ones in front. Anything that was in the x term, we would want to have a leading one there, and we would want to have sort of this triangular format so that we could do back substitution. I'll show you in the next slide what that looks like. And then there's something further called row echelon form, where you have ones sort of on the diagonal and zeros everywhere else. I'll show you what I mean by that. Sorry, I don't have an example. For row echelon form, what we mean is we would have, let's say, 1, 3, 5, 2. And then we'd have a 0 here, 1, -6, 8. This line here represents the equal sign. And then let's say we have 7, 14. So this would be a row reduced matrix. Again, this first column represents x, this represents y, z, and this is everything on the other side of the equal sign. And looking at this last equation, we would say, oh, well, that says that 7 times z is equal to 14, so we could solve that to say, oh, z is equal to 2. And then go back to the next equation above, plug in z to find y, and then go up, plug in z and y to find x. So we do this back substitution. All we've done is just gotten rid of the x, y, and z variables. When something is reduced row echelon form, we have already solved the matrix pretty much completely. So we have zeros everywhere except for on the main diagonal. And in this case, it's easy to see what the solutions are because, again, this column represents x, so we're saying, oh, x is equal to -2. And this column represents y, so we're saying y is equal to 4. And this is z, so z is equal to 8. So when it's completely reduced in this way, we're able to see the solution. There's a series of steps that we use to get to this, but again, because you can readily find matrix calculators online, I'm not going to spend too much time going through the algebra. Those of you that will take linear algebra, your professors will start from the beginning and teach you all the steps. But just to recognize which matrices are in row echelon form, matrix A and matrix D in this case are in row echelon form because there are ones on the diagonal, and then everything below the ones are zeros. Matrix D is in reduced row echelon form. It's got that extra bonus of having zeros in the upper triangle as well. Looking at matrix D, we don't have ones anywhere, so that's not meeting our criteria. And then for matrix C, we have this row of all zeros, and that actually is supposed to be all the way down at the bottom. Any kind of zeros should be down at the bottom. So in this case, it looks like these two rows should be interchanged. In this example, we're going to use a matrix calculator to solve this system of equations. Again, we could go through all of the steps, and it looks very similar to what we did when we were solving systems of 3 equations. But what you're going to do is, if you go to step 1, back up for a second, is looking at this matrix that's drawn here and seeing how this is the matrix form of the system of equations that we've got here. We're taking just the coefficients in each of the cases. For the x column, we have 2, 1, even though it's not written there, and then 3. So we've got 2, 1, 3 written here. For the second column, -1, -2, and then we put a 0 as a placeholder because there's no y in that third equation. So this is the augmented matrix for the system of equations that's up above. If we go to a matrix calculator, it would simplify this for us and give us a solution. Let me see if I can do this. Hang on. I've gone to this matrix calculator. I'll give you the web address later, but this is really cool because it has ads, but it'll do all the calculations for you. And so we're trying to do Gauss-Jordan elimination. And the matrix that we were looking at has 3 rows and 4 columns. So I type that in here and then hit set matrix. And then it'll let me type in the coefficients. So 2, 1, 3. I'm just typing in the numbers that were the coefficients in front of each of the variables. And then -3. -6, 7. This saves a lot of time. Then I'll hit solve. And it tells me that x, they're using x1, x2, and x3. X sub 1 meaning x. In our case, x sub 2 is y, and x sub 3 is z. So here's our solution, 3, 7, -1/2. And that should be the solution that makes all 3 of those equations true. So we got 3, 7, -1/2 as our solution. So that's a lot quicker than what we were doing in the last video, solving everything one at a time. The entries of a matrix are typically denoted with a double subscript, the first number representing the row and the second one representing the column. We use capital letters for labeling an entire matrix, and then we use lowercase letters to denote the individual entries into a matrix. So this here is the entry in the first row and the nth column in this particular case. If every single entry in a matrix is equal to that in another matrix, then that's the way we'd say that both matrices are equal to one another. To add matrices together, we're just going to add the entries that are in the same position. And so in that case, to add or subtract matrices, they have to be the exact same size. So here would be an example. For the first example, I've got two matrices that are 2 by 2, right? 2 rows and 2 columns. And so to add them together, A plus B, I'm just going to add entries that are in the same location. So first row, first column, I'll add those together. So that's a 1, right? And then let's do first row, second column. That'll give me a -3. And then continuing with 4 plus 2 is 6.5 plus 3 is, let's just write that as 3.5. We could also subtract A minus B, right? We'll just do -5 minus 6. So that's -11. And then 0 minus a -3. That's going to change to a +3. 4 minus 2 is 2. And 1/2 minus 3 is, that'll be -2.5. Second example here, A plus B, I'll just add each of the entries that are corresponding. In this case, these are 3 by 2 matrices, 3 rows, 2 columns. So 1 plus a -1 will give me 0. 3 minus 2 is 1. -1 plus 1, 0. 3, 12, 1. Again, I just added each of the corresponding entries. And then for A minus B, 1 minus a -1, that's going to become +2. 3 minus a -3, that's going to become a 5. -1 minus 1, that'll be -2. 5, that's going to change to +2, right? 5, 5, that'll change to +2, so that's 7. 6 minus 6 is 0, and 0 minus 1 is -1. Again, you could go to that matrix calculator and it would do these calculations for you. Scalar multiplication is just taking an existing matrix and multiplying every single entry by a number. So 3 times the matrix A is going to take each entry and multiply them all by 3. Negative A would be multiplying every entry by a -1. Matrix multiplication, where you multiply two matrices together, is actually more complicated. This is the formal definition. I'm going to show you an example of how we carry this out, though the matrix calculator will do these calculations for you because it's kind of a lot of moving parts when we do this. One of the things that needs to happen is this first matrix that we have is, in this case, it's a 2 by 3 matrix, and this one is a 3 by 2 matrix. To multiply, these two numbers have to match. The number of columns in the first matrix has to match to the number of rows in the second. And the resulting matrix is going to be a 2 by 2 matrix. Okay, so here's the website to the online calculator that I was using. It's pretty easy to find and it's free. So let's do matrix multiplication twice. We'll do A times B and then B times A. So I'm going to rewrite the matrices here next to each other. 3, 1, -1, 2, 0, 3. That's A. And then B is here. And we said that we're going to end up with a 2 by 2 matrix, right? Actually, I'm probably going to need a little bit more room here because I'm going to write out in detail what the calculation is. Okay, this is going to end up being 2 by 2. Now, when I start right here, this is the first row and the first column, right? So I'm going to grab the first row from this and the first column from this. The rows are going to come from the matrix A and the columns are going to come from the matrix B. Notice I have 3 entries in each of them. So I'm going to multiply each entry as they are in order. So bear with me for a second. I'm going to take 3 times 1. The first entry in row A is a 3. The first entry in column B is a 1. So I'm going to have 3 times 1. And then I'm going to add that to the second entry multiplied by the second entry. 1 times 3. And then I'm going to go to the third entry, -1 times a -2. That's going to end up being my first entry in my matrix. Okay, now I'm going down to the second row. Oops, go back because I lost a number there. It's a 1. Okay, I'm going to go down to the second row and stay in the first column, and I'm going to go here, second row, first column. I'm going to take the entries one at a time. So I'm going to have 2 times 1 plus 0 times 3 plus 3 times -2. I do 2 times 1 and then 0 times -3 and then 3 times -2. I'm going systematically one entry at a time. Now we'll move to back up to the first row, but now the second column. First row, second column is going to go here. We have 3 times 6 plus 1 times -5 minus 1 times 4. And then our last second row, second column, 2 times 6 plus 0 times -5 plus 3 times 4. All right, so let's put this all together, and we're ending up with here I've got 3 plus 3 minus 2, which is, wait a minute, oh, plus 2, 8. Here I've got 18 minus 5 minus 4, so that'll be 9. Here, 2 plus 0 minus 6, 2 minus 6 is -4. And then here, we've got 12 plus 12, we've got 24. So this is my final solution here, this 2 by 2 matrix. All right, let's do one more example. This time we're going to do B, matrix B times matrix A. So matrix B was, let me scroll down a little, 1, 3, -2. 6, -5, 4. And then matrix A, 3, 1, -1, 2, 0, 3. Okay. This is a 3 by 2 matrix. This is a 2 by 3 matrix. These both match, and the result is going to be 3 by 3. The result is going to be a 3 by 3 matrix. Okay. First row, first column. We have 1 times 3, which is 3, plus 12. 1 times 3 plus 6 times 2. I'm going to move over to, I'm going to stay in the first row, go to the second column. I'm going to have 1 plus 0. First row, third column, -1 plus 18. Okay, let's move down to the second row. Second row, first column, 9 minus 10. Second row, second column, 3 plus 0. Second row, third column, -3 minus 15. Okay, third row. Third row, first column, -6 plus 8. Third row, second column, -2 plus 0. And then third row, third column, 2 plus 12. Again, we don't really do this by hand very much anymore because we've got matrix calculators, but back in the day we did this all by hand. So our final answer here is going to be 15, 1, 17, -1, 3, -18, 2, -2, 14. 3 by 3 matrix as we were expecting, and that's our answer. All right, like I said, you can look these up using that matrix calculator here, matrix.reshish.com. There's a ton of them online. Thanks for watching, and I'll see you in class.